m plus log base A of n. We also had a quotient property on three of these. And that was listed as, in your textbook, log base A of a quotient can be described as a difference. Log base A of m subtract log base A of n. And the last one that you're responsible for, power property. Your textbook chose to write like this, log base A of, I think it was m raised to an exponent of r. That's what it was. And all they did was to rewrite it like this, with the r being lifted out front. Those are the only three properties of logs. Like I said, I'll finish up chapter 4 on Monday. Guys, did I get a chance to at least discuss somewhat this yesterday? In class, you guys recall this a little bit?
Last one.
Oh, not the power property? Okay, now all three are there. That way these come from the middle school properties for exponents. Now all I want to do today is show you how to apply some of this, and I'll feel better about where we should be here. Guys, the first one looks like this in part 2 from your handout. I'm going to do an ln, a natural log, we talked about that yesterday, of this expression. That's over this. They're asking us to use the properties to rewrite this. I think you're going to like this compared to some things we've already done in class. I think this is going to be much, much easier. Guys, when I look at this, they're saying, please split this up, rewrite it using those three properties on the side there, into a more simple form. Now, which of the three properties might I start out with the way it looks? To begin. Okay, this is a quotient. So if I jump to the quotient property, which says, show this, show the difference of the logs. So I can quickly, step 1, with the help of the quotient property, rewrite this as ln, natural log, of 5x, square root 1 plus 3x, and subtract ln x subtract 4 cubed. Now can I go further? Step 2, I look back at step 1. This is a product inside the first term. Therefore, I could apply on the first term the product property next to it. We're going to do that right now in that first term. As the product property says, split them up, add them. So it's like this as ln of, and be careful here, 5 plus ln x plus ln of that square root. And I'm going to leave my term down here just like it is for right now. So all I did was to apply the product property on the first term. Now take a look, please, and tell me, is there anything else I could do using another property? Yes?
Since the natural logarithm of square root of 1 plus 3x, isn't it the same thing as 1 plus 3x to the power of 1 half?
That's what we're going to do now. Hey, he says, Professor, I think you can go further. You can think of this square root of 1 plus 3x absolutely as 1 plus 3x raised to the 1 half. That's the first thing he noticed. And therefore now I might be able to use which property? The power property. I have some powers to work with. Be very careful here. ln of 5, leave it alone. It's fine. ln of x, it's in good shape. Now when I reach this term here though, with his help, the power property says I'm allowed to bring that power, in my case 1 half, out front as this formula is a rule. So it's right rewrite this as 1/2, being lifted out front, ln of 1 plus 3x. As I do it there, which is finished, I also see a power on the end. So that power property can be used again. Take the 3 out front, and minus 3 ln x subtract 4. And guys, I don't see anything else to be done with it. So this is the original up there, split up with the help of the properties into some other simple terms to work with. Okay? So when you reach that calc class, and they're going to ask you to do a derivative or some calc technique, I keep on mentioning calculus, and they give you this would be a mess if you left it all together like this to do a calc technique. So they're going to ask you to please split it up first into simpler parts. Got any concerns with that first example? Just applying the properties? Okay, let me do something else here. The next one looks like on your handout this. Simplify, call this part B. Log base 2 of this. X times the square root 1 plus x squared. Now before I jump into it and try to simplify it by using those properties, I know it's tempting to say, Professor, isn't that a perfect square root? Isn't the square root of 1 plus x squared 1 plus x? Is it, guys? No. So tempting to think it is, though. So when I jump into this one to try to simplify this into terms like we did the last one, guys, the original here that they gave me, all that is a product. So I'm going to apply the product property first, which allows me to rewrite this as log base 2 of x plus log base 2 of this square root. That's merely product property. Now, does anyone see anything else that can be done with the help of a property to go further? 1/2. Yeah, the 1/2, the right here, like Aiden told me last time. This could be written as 1 plus x squared raised to the 1/2, and therefore let's rewrite that with the power property and have this now written as log base 2x plus 1/2 out front log base 2 1 plus x squared. And that's all I can do with it. Now, have I had students say, hold on, Professor, can't you do this? Can you not do something almost like a distributive property? Log base 2 of 1 plus log base 2 of x squared. Can't you do something with that? Don't you think I could do that? No. There's no property that would allow me to do that. So we're finished. Looks like it's tempting, but it will not work. And if I get this out of the way now. I'm going to jump into this now. Part 3. It's all on your handout. Here's one that, oh boy. Okay, ln, just write it down and I'll describe this to you. X over x minus 1 plus ln x plus 1 over x subtract ln x squared minus 1. What they've done this time, they've already split this up for me. They've already applied the properties. They want you to put it back together as one single log. So guys, is equal to 1 log, what logarithm, in this case ln, did all this come from? And it's already been split up for you. Some hints, there are some hints here. I see a plus sign, subtraction sign. That plus sign may indicate which property, if you're thinking backwards. product property, and then that subtraction sign says quotient. So if I can put all that back together as one log, here goes. So that means these two should be expressed as a product, x over x minus 1 times x plus 1 over x. That's those two. The subtraction sign indicates there's a quotient going on. So divide all this by x squared minus 1. You block that off. That's all put together. That's where it came from. Now, can I simplify this? Of course I can. X is canceled. We have x plus 1 ln of x plus 1 over x minus 1 here. And if they're asking me to simplify, which they are, I see a difference of squares in my denominator, which will factor into that. And now it looks like that. Now can I simplify further? Yes, go ahead.
What's the domain of this function?
Oh, beautiful. Oh, you want the domain. Hang on. We'll talk about domain. Okay, guys, if I go further, let's write this as ln of, and I'm going to do this on the side here. I can go further. It says x plus 1 over x minus 1. The top is being divided by, you think of it like this denominator. That's what this means. Which means for us, x plus 1 over x minus 1 times 1 over this for that division. Now, will something happen since I took the time to rewrite that? I think I could simplify. I think the factor x plus 1 will what? Cancel out? And I'm left with, looks like 1 over, watch my algebra here, 1 over x minus 1 what? Squared? Do I have 2 of those down there? Is that true? Now, if there's no mistake, all that put back together, I have ln of 1 over x subtract 2 squared. Is where all this mess came from. They already split this up for me. Now, I think I took this from your textbook. If I remember from the past, some students came in once who were doing their homework, and said, Professor, I think it was a homework problem. And they checked their answer in the back, or where the answers are for you guys. And it didn't quite look like that. And they became alarmed. Even though that is correct. But the answer in the textbook was not like that. Guys, look what they did in the textbook, which they could do. I'd accept that right there. They thought of this as x subtract 2 raised to a negative 2. And then they used the power property. They lifted the negative 2 out front, and they had their answer expressed as this. And my students became alarmed. They had this. They thought, oh no, Ramsey, I thought I knew what I was doing. The answer that was expressed in the textbook was this. So they did just a little bit more with it. Guys, how's that look? Pretty good? Mr. Park, Karina, I think I could put this on the board and my class today would accept it. I think today my class would accept that. Nima would nod his head. Professor, that's, yes, correct. Miriam's going to nod her head. Professor, that is correct. Why? Because my mind, Miriam's mind, Nima's mind is where? On that chest. So Professor, put anything you wish on that board. Make those logs look pretty. And make them just flow for you. And get all excited about it, Professor. Because my mind's somewhere else. So 2 plus 3 will be a 6 today. We'll accept. Yeah, that's where my mind is. Guys, how's this look so? Now, Farbot, you ask, here goes. You're saying, Professor, is there a restriction on the domain of all this we're doing? Because if we say functions, you got a domain. And he's wondering now, is there a restriction on the domain? Let me do one real quickly, and then I'm so concerned about this exam. We want to get started pretty soon. Here we go. F of x is equal to, let's say, log base 2, now look at this, that. Glad you brought this up. Now, a reminder, if, from the past, if that function had looked like this, and you were asked to find the domain from the past, what would you do? Who remembers how to find the domain if it had a square root on it? Aiden?
Just say, x squared minus 1 is greater than or equal to 0.
We did those. And then you finish it up. One likely to use sign analysis. We did those. Now, some of my students are ahead in the homework. Does anyone know, is there a restriction on, I see the restriction on square root. Is there a restriction on a log? If there is, I'll use that restriction and find the domain. Guys, does anyone know the restriction here? The restriction on the square root is this, which makes sense. Does anyone know what the restriction on it in a log is? I see a hand going up. Aiden?
Well, it can't be a 0.
It cannot be 0. I can't take the log of a 0. Can I take the log of a negative number?
No.
No. Therefore, I think then inside there must be greater than 0. Cannot be equal to 0. For the square root, you could include 0. For a log, you can't. So here, this part here, called the argument, must be that. And then you can factor this, find your critical numbers, go to our number line, use sign analysis, that's one way to approach it, and get the answers. The guys, that part inside there must always be greater than 0. You cannot take the log of 0, cannot take the log of a negative number. Okay, yes?
But you gotta consider other logarithms.
Got you.
As well.
Far about. Let's look at this class. He said, wait, Professor, should you also consider the domain, right? As you do these problems over here where you're using properties, should I also, in my mind, to make it look nice, should I go ahead and use your properties here? Finally end up with this, I think we end up with this, finally. But should I also take into consideration the domain here? Well, if I did, they may not ask you to do it on a problem like this. Can you tell me right quickly, this would have to be, look at this. Oh, I'm glad you asked. With that part inside there, it has to be greater than 0. Now, can anyone tell me if I continue further? I'm so glad you asked. Now, suppose I continue here and ask you, at this point, what is the domain just on that first term? How would you approach it to find the domain? Over there, I could factor and use sign analysis. How about this one? If that should happen, how could you find the domain? What procedure would you use, routine, to get the domain of this one? Can I still use sign analysis?
Everything except between 0 and 1.
There you go, there you go. If you find critical numbers from the top and the bottom, you said x equal to 0, there's a 0 you mentioned. If you set this equal to 0 and solved, you get 1. So yeah, you go to a number line, look at this. And you have 0 and 1 open, and you go through then and do as we always do, what, test? Check a number and see what works, and then you shade in. And guys, stand here right quickly, to save me a little time here. I want that to be a positive. If I try out here, -1 maybe, a negative over a negative, oh, that's gonna work. In between, I can try 1/2, that would be a positive over a negative, can't use it. Out here to the right of 1, let's try maybe a 3, that would be a positive. Or about it, glad you asked. Just that first term for its domain is -infinity up to 0 union 1 through infinity. Now, whether or not they're going to ask you to list the domain for a problem like this, they may not. They may just ask you to use the properties. Guys, at least you got to start, right? Oh my goodness. Yeah. Please. 2 plus 3 is equal to 6. On exam day, whatever you put on that word, Professor, I'm gonna nod my head. Yes, yes, yes. Until I get a copy of that exam, then you might see my head shake the other way. Oh no, that problem's not on the test. Oh, there it is. There's that ball being tossed up in the air. There's that fencing problem. Guys, any quick questions? Now guys, just maybe a couple minutes. Anything you're concerned about, the 2 o'clock session, had questions, definitely, relating to the test, and we got some things done. But if you did not attend, does anyone have any quick questions? I know the test is coming up. I want to see a good job on this. And again, the TAs will have some extra credit for you, next week. We'll talk about it. Okay. Yes?
Can you do one practice problem maybe?
Whoa, whoa, whoa. What type of practice?
Like absolute value inequality.
Let me do it. What are you doing? Absolute value what?
Absolute value of x plus 3 over negative 4.
Whoa, hang on. All this inside like this?
Yes.
I suppose it, okay.
Is less than or equal to 2.
2?
Yes.
Oh, class, he helped you out. Boy, he helped you out. Now, first thing, if you use the rules here, you quickly say, I realize by rule here that tells me that the inside there that he gave me is caught between negative 2 and positive 2. Is this true, guys? If you follow the rule. Yes? No? Is it true? And then what might you suggest I do now in an attempt to solve it? What would you do now if you saw this staring at you on the exam? What are you going to do next? And that was a negative 4, right? Okay. Oh, by the way, you know what I should do also? I've got you. Could I, since that bottom part's negative 4, is the absolute value of negative 4 4? Could I take that out immediately and therefore call this just over, in this case, what was it? I was going to rewrite it for you. Here we go. Absolute value of x plus 3 over 4 is this. Does that make sense, guys? I could, if I wish, rewrite this like this before I get started. Is the absolute value of negative 4 4? Do it that way. And then do what to finish up here? Put this between, here we go. Did you attempt this problem yourself?
No.
No. I could say, wait, hold on, the bottom part is a 4, for sure. So I could quickly put a 4 down here and get rid of that absolute value. But still have this, and use the rule here, caught between negative 2 and a positive 2. And then multiply through by what? 4? Makes this negative 8. Less than or equal to x plus 3. Less than or equal to a positive 8. Multiply everything by 4. Thank goodness that 4 was positive. Subtract 3. Looks like, and I did it quickly, that might be the answer. What do you think, guys?
And the same thing, the signs were switched.
Yeah, back here, the signs would be switched if I had left this like this.
Yeah.
Absolutely. If you do that, I thought, oh, maybe I should go back and go ahead and get rid of that negative 4. That absolute value of it's 4. I see exactly what you're looking at. And that was, therefore, I need not worry about the sign reversing on me. You can go ahead and do it like this also, but the sign will reverse. A little bit tougher, but we'll get the same answer. Mike?
Can we just leave the answer like that, or do you want it in notation?
Yeah, the interval notation?
Yeah.
Gotcha.
Or does it matter?
No, I'll be asking for interval notation.
Okay.
If you got something, and this, right?
Is that true, guys? Far behind. We're going to close down here. But if you've got something like this and you've got a little time, you're going to plenty of time tonight. I would maybe try something either in here and see if it works back in the original, just to make sure. Or maybe try something outside, which should not work, just to make myself feel a little better about my answer. In other words, if I try a 6, if all that math is correct, if I take a 6 back, it shouldn't work.
Divided by.
Is that true, guys? Take it back to the original. If I put a 6 in there, what is that? 6 plus 3 is what? 9? 9 over a negative 4, what is that? 9 over a negative 4, and you take the absolute value of it. Is that going to give you a positive 2 1/4, I think it is? Is that less than or equal to 2? No. But if you try something inside here, like 0, it hopefully would work. So 0 in here, you end up with, I think, what, negative 3/4? And the absolute value is what, positive 3/4? And 3/4 is less than or equal to 2. That'd make me feel a little better. Okay? Now, I will tell you before we close down, some of my students in that 2 o'clock session, and I think it could apply for all of us. There's a lengthy problem on there where you have to complete the square of the test. I know that's a headache, so you've got to be very careful with it. After you think you have it, you have to take 1/2 of this and square that, and put those blanks in there some way and all that business, and you think you have it. I would go on the side and do it by the shortcut and see if I start ending up with the same numbers for that vertex. If not, I've made a mistake back on my completion of the square. Okay? Guys, any questions? Who would like to for their paper to be scored first? This weekend is our score. I see a hand go, oh, I see some hands going up here. Oh, man. I see another hand back there. Arena.
I have a question.
There, okay, hang on.
What if in this inequality we would not change the sign to the floor?
Because I went ahead and took the absolute value of that bottom part, which is negative 4.
For example, I'm not taking the absolute value.
Oh, then yeah, exactly. The symbols, or somebody brought that up. Who was it? Aiden, was that you? Somebody did. Yeah. Oh, there you go. The symbols would, the inequality symbols would reverse.
So the sign is reversed.
Yeah, signs will reverse. Absolutely. That's what he was asking about also. Arena, even if you did that, it's messy. Right here. Look at this. Oh, you guys are good. This is what? 8. This changes. X plus 3 changes. Is that the way it looks? If I go through and multiply everything by a negative 4. And I reverse my symbols.
It's a negative 8.
It's a negative
Where was it? Over here? A negative 8.
No.
That's true? And then, you know what I would do? It looks messy. I might want to separate them into 2 parts. I think this is what you guys are about. I might want to say, wait, Professor, let me just bring that part out, deal with it, and then bring the other part out and deal with it, and then see what they have in common. Arena, that's exactly what I would do there. I would split them up into 2 parts. I hope it leads you to the same answer I have. We hope. Make sense? Can we split it up, Mr. Park?
That's kept together, so it worked.
Oh, you kept it together?
Yeah, it worked.
Oh, okay.
Oh,
Got
right.
anything else?
No.
Now, take your, yeah, it's 15 minutes. Take your 15-minute break, and we'll get started.